Everybody, it's Tyler here at Kettering 1, checking in with 573 Mech Warrior from Bloomfield Hills. Mech Warriors have been looking great so far. Played a couple matches, and the robot's been operating fantastic. And a lot of great things on the robot we'll be highlighting. Especially take a look at how they're doing their deep climb as well too. Hooking up underneath is definitely a unique way to go about it. It's been working out great for them so far. We'll be featuring a bit more about this whole package design, what's gone through it, talk a little more about their auto alignment, and really what goes into this awesome machine coming up here on Behind the Bumpers. Let's start taking a look at the coral journey on this robot here. You guys have been so effective on the field, so walk me through some of the great elements that have gone into this.
All right, so over here we have our human player ramp where we intake from the human player station. Typically, we have the human player send it vertically, but if it winds up going horizontal, these can move a little bit and bounce so that the coral ends up vertical into our end effector right here. We designed our end effector to completely rotate like this when we want to remove algae from the reef and score it in the processor. We were working on trying to get it into the barge, but our soft stops in our code are preventing us from doing that right now. So we're trying to get that sort of squared away for our next competition.
Can you talk a little bit more about this coral algae dual thing here? How you kind of came up with it and why it's working out so well?
Well, we saw another robot do something similar, and we liked how it could do both algae and coral at the same time because we were having issues with packaging our previous design. So we looked at their CAD model and then created this based off of that. Our main difference from that was we added this whole top section because on the robot's design they didn't have it, and it looked. We were worried about the coral falling out prematurely, so we added this top dead roller, which all it does is compress the coral a little bit to prevent it from shooting out completely.
And you're running a 2-stage elevator on there. How effective has your L4 scoring been so far?
It's been like the easiest scoring method that we've been able to do. It's easy to see, it's easy to score.
Really delighted to hear that. Let's pass over to Michael and talk. We really got to highlight this climb. This is really cool. You know, when we talk to so many teams, we see just a lot of every bot climbs. Your team has gone a different route, and it's been working out great so far. Tell me more about it.
Yeah, so to start off with our climb, we knew that into this game it would be a lot trickier with a swinging cage being completely square and being so heavy. So going into the season, we had to decide, oh, well, we have to be able to climb at least a little bit off the ground to count for 12 points and be able to earn a ranking point easier. So we took our approach towards thinking about how we can orient the cage, and we thought of our reaction bar from last year on a robot where it would react with the center stage of Pegasus and be able to hold itself up. So we thought we can use basic torque and physics to understand that the cage would be locked in between these two bars, And so these two bars are at this certain distance to go under. It'll push the cage into this area, and it'll be funneled in through these funnel plates here made of Lexan. And then we'll start going back up, and we'll pull the cage with us, locking it into these wheels, and therefore lifting us off the ground. And a great part of this is we have been able to orient this to function with our ramp, as the issue with bringing our cage into the robot is this ramp would have been in the way. So what we do is we have a passive mechanism that will, when we drop the climber, the ramp will drop as well, allowing us to climb with the cage. And we really wanted to do this because at 573, we feel that passive mechanisms are very important for keeping our robot simple and keeping operating it and operating on it after a match also simple.
Have you noticed this type of climb maybe gives you a little more versatility versus some of the other climbers we've seen out there? Like you get a little more kind of tolerance on how you climb, that sort of thing?
I would definitely say that we have a lot more leniency when climbing, as we can push the climber in any way we want, and these funnel plates, as mentioned before, will keep the cage in the square position we want it to be. one more thing I'd like to add is something else we do a lot here at 573 is we take pride in our 3D printed parts. And down here in our climbing mechanism, we've implemented a servo that will activate this 3D printed pawl that'll lock into these motors, keeping us suspended from the ground without the cage actually falling.
Overall, this is a great package robot so far, so congratulations on putting it all together. But we got to talk on the software side of things as well, too. So, Maddie, walk me through a bit more how your auto alignment's working. Anything else you want to add in from that perspective?
Yeah, so our auto alignment is a big part of our robot this year. It's probably the best that it's been since I've been on the team. We can essentially, anywhere that there's an April tag on the field, we auto align there. So whether that's like at the barge to help us auto align for climbing on the cage, with a deep climb, or especially at the reef. So our autonomous modes rely heavily on the April tags, but also our driver and operator use it a lot during the match. As long as our cameras can see an April tag, the robot will start moving towards it and then start angling itself towards the reef to get in the exact position it needs to be. And with that also comes our set points. So we have set points for every level so that our operator doesn't have to do as much manual control and only selects where we want to score. And then the robot will articulate itself to be in the exact position it needs to be for that level. And it works the same way with our algae system. So if we need to displace algae from the reef or collect algae to score in the processor, we use auto alignment and set points in order to go into the exact position we need with little room for error so that our driver and operator don't have to focus as much on the small movements that it takes to get in the exact position to score coral on the reef.
Like I said, overall, it's a very complete robot here. So, Mech Warriors, congratulations on the great machine so far. We can't wait to see how you do here at Kettering 1. So, best of luck to you.
Thank you.
Thanks for giving us an overview of this machine, and good luck the rest of the way.
Thank you.